Hello all, let's start again section 2.1. In this video I'll discuss part 2 of the solving quadratic equations. Method 2, as you see in the topic, it's completing square. Let's first discuss what is completing the square, and after that how to solve quadratic equations using completing a square. As I mentioned before in my first lecture, that some of quadratic equations you cannot factor them to easily solve. They don't have factor, and that's why it's difficult to factor, or sometimes it's not even impossible to factor. That's why you need to use another method to solve quadratic equations. For example, if you focus on this example, I have x squared minus 2x minus 4 equals 0. There is no way to factor this equation, correct? Or this trinomial on the left side. Then how to solve such a kind of quadratic equation? Of course we can solve it. One of the methods are completing a square. What is completing a square? Remember when I did an extra lecture for you, I used this a plus b, a product of a plus b square, or a plus b times a plus b. On the right side, if you FOIL this and multiply two parentheses, of course it gives you a plus b times a plus b, correct? If you multiply these, FOIL it, you will end up with a squared plus 2ab plus b squared. Or if you have a negative, both of them is negative, you will end up with a squared minus 2ab plus b squared. This is one of the identities in algebra. An identity means both sides of the equation, they are the same. They are the same, correct? At the same time, we call the right side of this identity a perfect square trinomial, correct? A perfect square trinomial. Even I discussed why. Because if you take the square root of the first term, and if you take the square root of the second term, and if you multiply this by 2, it gives you always the middle term. You see, 2ab. That's why we call it a perfect square trinomial. Now, all trinomials, we know they are not perfect square trinomials. Like this one, which I put in this example, x squared minus 2x minus 4, it's not a perfect square trinomial. Then, how to deal with this? We can change it to a perfect square trinomial. Doing what? I will write some steps for you. Step number 1, or step 1. Let's put 1 here also. Step 1. And step 1, take half of b. I will write b, but I'll explain what is b. I know you're sure because we discuss a lot the general form of quadratic equations. You know b means the coefficient of x. Take the half of b, or I can say coefficient of x. B means coefficient of x, right? And square it. In step 2, add this number to both sides. Because we are talking about equations here, I will say add this number to both sides of the equation. But if you do only on a trinomial, it's not an equation, add the number and subtract the number. Maybe some professors goes this way, but because here we are discussing the quadratic equations, because I have two sides of the equation, I will say add this number to both sides of equation. These are the steps. I don't want to write a lot of steps. I'll show you how you can do this, correct? How you can do this. Let's move up this one a little bit up. I can show you. The given equation is x squared minus 2x minus 4 equals 0. B, which number is B? The coefficient of x, this one. Take the half of it. Let me explain. How to take the half of it? Half means divide by 2. Or in other words, multiply it by 1/2. Divide by 2 or multiplying by 1/2 is the same, correct? And after that, square it. I'll show you in a red pen here on the right side. 2 cancels out with 2 and you end up with 1 square, which gives you 1. For example, if the coefficient of x was 3, correct? If you multiply it by 1/2, it gives you 3 halves, correct? You will end up with 3 half square, which means 9/4. For example, another example, I'll explain all the conditions for you because you will deal with different types of them. For example, the coefficient of b was a fraction, like let's say 3/5. How to take the half of b now? Multiply it by 1/2. Always multiply it by 1/2, correct? Excuse me, there was a kind of, my phone was ringing. If you multiply it by 1/2, it means you take the half of b, which you end up and square it, which you end up with 3/10. 3/10 square. And everyone knows what's 3/10 square, 9/100, correct? Whatever the coefficient of x is, take half of it, square it, and add to the both sides. When you are dealing, I'll add one more step here to make it easier for you. When you are dealing with quadratic equations, the best thing to do is first move your constant term to the right side. Only and only when you are doing the completing square method. Move your constant term, or the name is C, to the right side. Rewrite your equation like this. X squared minus 2x equals, moving -4 to the right side means add 4 to both sides, right? Some professors show it to you this way. Some of us, we call it move it to the right. Move it to the right means change the sign and write it down on the other side, correct? Now take the half of b, square it, and add to the both sides. It means do this. X squared minus 2x. What was the half of b that we squared it? It was this number 1. I will add 1 to this side, and I will add 1 to the right side, to both sides. Simplify the right side, and you can see easily that your left side becomes a perfect square trinomial. If you say no, test it. What is the square root of x squared? The square root of x squared is x. What is the square root of 1? Is 1. And if you multiply this by another 2, it gives you the middle term. You see that? Automatically it becomes a perfect square trinomial. Now, what is next step? Instead of writing x squared minus 2x plus 1, I can open a parenthesis. I'll take the square root of the first term, which is x. I will copy the sign from the second term. Always take the sign from the second term, negative, and take the square root of the third term, which is 1, and square it. X minus 1 all square equals, simplify the right side, 5. Now, this equation is really easy to solve. To solve an equation, take the square root of the right side and take the square root of the left side. Square root of x minus 1 all square equals plus minus the square root of 5. Cancel 2 with the square root. It means you end up with x minus 1 equal plus minus square root of 5 or radical 5. Now add 1 to both sides and you end up with the solution, which is x equals 1 plus minus the square root of 5. Two roots. One of them is 1 plus the square root of 5 and the other root is 1 minus the square root of 5. We call this method completing square. Correct? It is not difficult. It is a little bit long, but soon after I discuss the quadratic formula for you, you will see that yes, it's easy because the quadratic formula is actually a shortcut for the completing the square method. Correct? I'll do now another example for you. Let's practice like 2-3 examples to know how to deal with these uh, quadratic equations using completing square method. Let's put another example. Let's do another example. Example 2. Solve. And the equation given to you is x squared plus 3x minus 5 equals 0. Correct? We cannot factor. There is no such a 2 number. To multiply gives you 5. To add gives you 3. Definitely there is no such a number. Then what I do, I'll use completing the square method to solve this equation. Correct? First, I'll move my constant term to the right. X squared plus 3x equals positive 5. Now, I'll write my first term. I'll write my second term. I'll take the half of b, or the half of coefficient of x. Half of coefficient of x is 3 times 1 half. It means 3 halves. And I will square it and I will add it to both sides. When you square this, it gives you 9 over 4, right? It means I'll add here 9 over 4 and also I will add 9 over 4 on the right side. I got 3 terms. It's a perfect square trinomial. No need to test it every time. Oh, is this a perfect square trinomial? Yes, for sure, 100%. I'll tell you, when you do this process, your left side automatically becomes a perfect square trinomial. Then open up parentheses, take the square root of the first term, sign from the second term, which is positive, and take the square root of the last term. What is the square root of 9 over 4? Of course, it's this number, you see, on the right side, 3 halves. And put a square on the top of the parentheses. Equals, simplify the right side. 5 over 1 plus 9 over 4. You need a common denominator. It means multiply 5 by 4, right? Or the other way, I don't know if you know this method or not. 9 plus 9 over 4. Multiply this two number. Whatever the result is, add with the top. It becomes your numerator. 5 times 4 is 20. 20 plus 9 gives you 29. Over what? Over 4. Or if you go this method, it's the same, correct? You will end up with 29 over 4. Now, take the square root from both sides. Square root of x plus 3 over 2 all square equals plus minus square root of 29 over 4. Here, square cancels out with the square root. X plus 3 over 2 equals plus minus 29 doesn't have a perfect square root. You can keep that one under the radical, but the square root of 4 is 2. Now move 3 halves to the right. It means subtract 3 halves from both sides. You will end up with your final answer. X equals negative 3 halves plus minus square root of 29 over 2. Or you can rewrite your answer as a one single fraction. You see, denominators are the same. Then I can write x equals one big fraction, 2 in the top, negative 3 plus minus square root of 29, and that's your final answer to answer. Correct? Negative 3 plus the square root of 29 over 2 and negative 3 minus the square root of 9 over 2. These are the roots of the quadratic equation. Correct? These are 3 examples. Of course, I assigned some homeworks. You can practice with just write a quadratic equation and try to apply the completing a square method. One more thing that I want to add for you here, that how to deal, because every time you will not end up with such a quadratic equation to the coefficient of x squared should be 1. No, sometimes the coefficient of x squared is not 1, correct? You have also a number. For example, let's do one more example. Actually, I want to do one more for you to show how to deal with a quadratic equation if the coefficient of x squared is not 1. Because in 2 examples that I did for you, both of them were easy. The coefficient of x squared was 1. But what if it's not 1? Let me copy an example from your book. For example, 4x squared minus 12x plus 9 equals 0. You see here the coefficient of x squared is not 1 anymore. It's 4. In this case, first divide all terms by the coefficient of x squared, even before rewriting, even before moving your constant term to the right side, correct? I will divide all terms by the coefficient of x squared, whatever is that, right? If it's 3 divided by 3, it's 4 divided by 4, whatever the coefficient is. Here 4 cancels out with 4. I'll end up with x squared minus 12 divided by 4 gives you 3. We are still lucky that you don't get a fraction here. Sometimes you end up with fraction. Who cares? I already explained to you how to find the half of a fraction. It means just multiply the denominator by 2 or multiply your fraction by 1/2 and square it, correct? Plus 9 over 4 equals 0 divided by 4 gives you 0. Now, I will subtract 9 over 4 from both sides. It means move your constant term to the right. You will end up with x squared minus 3x equals negative 9 over 4. Next step, start completing a square. Take the half of b, square it, add it to both sides. Means x squared minus 3x plus 3 over 2 squared equals negative 9 over 4 plus 3 over 2 squared. Correct? From here to here is a perfect square trinomial. Square root of the first term, sine from the second term, square root of 3/2, all square is 3/2. I am in a pre-calculus class. I am not explaining why. You can see it. You have enough algebra on you to can understand. Equals, I'll simplify the right side. Actually, if you square 3/2, square it, you end up with 9 over 4. Agree? Now, what is negative 9 over 4 plus 9 over 4? You end up with what? With 0. Correct? What to do now? Take the square root from both sides. Square root of x minus 3/2, all square, equals plus minus the square root of 0, which is 0. Here these two cancels out. X minus 3/2 equals 0. It means add 3/2 to the both sides, and you end up with x equals 3/2. Only one answer, not even two answers. Correct? I told you that some equations you end up with one answer, some of them with two answers. Soon in part 3 of the lecture, when I discuss with you the discriminant. What is discriminant? Discriminant is actually something that tells you the types of the roots. Correct? The types of the roots. It can discuss with you the types of the roots. So it's really easy. Name is looking strange, but it's really easy formula. If you plug in few numbers in it, you will understand which type of roots your equation has, or how many roots your equation has. Correct? Next topic that I want to discuss before using formula in this part of the let me first discuss the quadratic formula. Okay, I'll stop the lecture here because I don't want to mix all the lectures for you, because it will be so easy for you to find in your canvas. Okay, I need to watch completing a square. You will click on part 2. I need to watch the factoring method. Click part 1 of the video. And I need to watch the quadratic formula. Part 3 of the video will be quadratic formula. I'll stop the video here and see you all in part 3 of 2.1, and we will discuss the quadratic formula there, and also we will talk about the roots, the product and some of the roots of a quadratic equation, and also maybe discriminant. I'll stop the video here and see you in part 3.